In this video, we're going to discuss the 10.2 material, specifically regarding how to work with completing the square. Now, our overall goal with this problem, in this section, is that we are going to create a perfect square trinomial on one side of the equal sign, factor that thing into the square of a sum or difference, and then find the answer using the extraction of roots process that we learned from section 10.1. So this is another tool that we're going to have at our disposal to go through and solve quadratic equations. It just requires some manipulation and rewriting ahead of time before we actually get to our final answer. I'm going to note also that when we refer to A, B, and C in this problem and through this process, I'm referring to something written in our standard form for quadratics in this ax squared plus bx plus c that we have here. So keep that in mind as we are going through some of these examples. Other things to note, and I would recommend writing the highlighted parts down with these, we need to remember the square of a sum and the square of a difference. These are going to come in handy as we are going through and rewriting our problems that we're going to see later on. And they're just shortcuts that we used from section 7.4 and how to factor something in one of these given forms into the factored forms that we see here. So again, review the 7.4 notes and video if necessary with that. So let's jump into our kind of starting part with these. Again, this is going to note that what we're looking at right here in this making a perfect square trinomial part is a very specific scenario that we're going to go through, very specific things we're looking at. It does not 100% translate to the problem that you are looking at. It will be modified to fit the problems that you were going to be seeing, but this is just to get an idea of how we're going to make a perfect square trinomial. So we're going to start with an example of assuming we have x squared plus 10x, and we're told to make a perfect square trinomial. What we need to do to make that happen is create the constant term at the very end. If we're looking at this compared to our two forms written up here, this current one in our example is missing this perfect square at the very end here, and that's what we need to make. Now, our process for doing that is we're going to take half of the b value, including the sign. You want to make sure you're including that. A lot of people forget that, and that gets them into trouble. And then we are going to square that answer. So I have two ways of writing this out here. It doesn't matter which one you use, they will get you to the same answer either way. I personally prefer to use this second one, as I think it's easier to work with when this b value is a fraction, which is not uncommon with these types of problems. I do want to note that when you are going through this step, and we'll see some examples with this later on, make sure that you are showing your work on how you're getting to half the b value and then squaring it and getting to an answer. There's a shortcut that we're going to go through here shortly, and then we'll see in some examples. It's going to save you some time showing your work now. So for this particular problem, we're going to take half of the b value and then we're going to square it. So our b value is 10. We have it plugged in there. Half of our b value is going to be 5. Now I have this highlighted for a reason. We'll get to that in a second. And when I square that, I'm getting 25. Now I'm taking that 25 and I'm adding that to the end of the starting equation. So I started with x squared plus 10x plus, I'm adding something, I don't know what. I just found out what that something is, and that's that positive 25 from right up here. So now I would need to create a perfect square trinomial and then factor that thing. So you can go through the entire factoring process from 7.4 or use the AC method from 7.3 if you'd like to factor this thing out. However, there is a shortcut that shows up here. If you show these three steps of work, or first step, second step, third step there, if you show those, the number and the sign inside of the set of parentheses here in the second step is always going to go at the very end of this set of parentheses that we have here. So I have a positive 5 in the parentheses. I'm going to have a positive 5 in the parentheses here. That is a shortcut you can always use if you use this method and follow the process that we're going to be learning later on in this video. So again, this example and this stuff that we have right here is unique only to show how we make a perfect square trinomial. This is going to be modified when we get to some actual example problems, but it's mainly just to show you how we are going to use half the b value and square it and put that on the end of the original thing that we've been given and we're starting with. So keep that in mind as we are going through this, but we're going to modify it fairly significantly when we get to actual problems, because there are some other rules and requirements that show up at these problems that we'll get to. So as we get to our actual process here, we'll highlight these, and I would again recommend pausing the video as necessary and taking notes of these, writing them down for yourself. The note that I do want to make before we get into this and we actually see some examples of it is that there are several methods you can use for completing the square. There are some subtle differences in the steps from the ones that I am presenting to you here, but all of them will get you to that final answer. So the one that I am providing here, I think, generally reduces the possibilities of errors along the way. There are other methods, again, that will work, but I think there are some pitfalls that show up with that I see is very common for students and people that are learning this process. And I think this one that we're going to go through here helps eliminate that from happening. If you want to use one of those other methods to solve some of these problems or other problems, you could use that, but that would be a different video you would need to find on YouTube or Khan Academy or something like that. So our first step in our process, we want to manipulate the equation so the constant term is on one side of the equal sign, the variable terms on the opposite side. So our goal is essentially to create an equation in standard form, but the constant term is all on one side, or constant terms on one side, I should say, and then the variable terms on the other. The next thing that we need to do in our process, and this might be the most important step of it all, specifically for this method, is that we need to obtain a coefficient of 1 for x squared. So if we're thinking to our standard form ax squared plus bx plus c, that a value absolutely must be 1. It's a big note here with this. If you're writing these out, I would star these and put a lot of reminders around this for yourself. It's absolutely required if the coefficient of a is not equal to 1. That means even if the a value is negative 1, I still need to rewrite it. This is a big step here that essentially will make or break everything else in this process. If you do not do this step, everything else falls apart. So once we've done that, step 3 says, from the variable terms, we're going to take half of the b value and square it. So that's the similar stuff that we did up top here. We are going to add the result to both sides of the equation. This creates a square of a sum, square of a difference on one side, and the opposite side will just be a number. So this right here is where we deviate from the process that we learned up above. Up here, we just added that number at the very end, and then we just found our answer and we were done. For actually applying this, completing the square in a full-blown equation that we're solving, we need to add something to both sides of the equation. Remember, if I add something to one side of the equation, I need to add that to the other side of the equation as well. We have to keep that balance in there. Now, once we've done that, on the variable side, we're going to factor the square of the sum or difference into its factored form. And again, the hint that I mentioned up above is still going to apply here. If we show our steps when we take half the b value squared, we end up just seeing that value, or half of the b value, get put in to this part of our fully factored form on that left side. We'll see some examples of this to get see where the shortcut comes into play, but this is a huge time saver right here. Again, I would recommend highlighting, starring, whatever that may be, for yourself as you need it as you're going through these problems. So now that we've created a perfect square trinomial on one side, we can then just solve the remaining equation using the extraction of roots method, or the square root property, that we learned in the 10.1 material. And I can go back and reference that video if you need to do that. If necessary, you can go through and then check your answers in the original equation, or you can check it using a calculator in that regard, kind of whatever you would need to check and make sure you have the correct final answers there. So with all of that said, let's go ahead and take a look at these 4 examples and see how we actually apply the process for completing the square to solve these equations. With our first example that we have here, we're starting off with the equation t squared minus 10t equals 11. So looking at our steps in our process that we have, the first thing that we're told to do, we need to manipulate the equation so the constant term is on one side of the equal sign and the variable terms are on the opposite side. So I have the constant over here, I have my 2 variable terms on the other side. Great, step 1 has been done for me. Step 2, I need to obtain a coefficient of 1 for x squared by dividing all terms by the coefficient of x squared. So in this case, we're using t instead of x for our variable, but that's fine. I'm still looking for this coefficient out front here to be 1. And we have the invisible 1 that's hanging out here, which is fine and great. That means step 2 has also already been done for us. Step 3 then says from the variable terms, we're taking half of the b value and we are squaring it. So I'm going to identify that the b value here is this negative 10. Remember that it's the number and the sign that's in front of it. Now my recommendation when you are doing this, make sure you are writing these steps out. Again, we have a shortcut that shows up with this later on in the problem. So I'm taking half the b value and squaring it. I'm going to then add that result to both sides of the equation. So I've identified b. I'm taking half of my b value, which is going to give me negative 5, and that'll be squared. And this is the thing that we want to write. This is the step that we want to have for ourselves. Now when I square this, I'm going to be getting 25. I'm then told I need to add this to both sides of this equation. So I have t squared minus 10t. I'm doing this in a different color only because some people like to have it highlighted for themselves a little bit as to what they're adding to both sides. You don't need to do that, but if you'd like to, you can. So I've added this 25 to both sides of the equation. Remember, in an equation, if I add something to one side, I need to add that exact same thing to the other side. That still applies here. So from this, we've just created a square of a sum or square of a difference on this side. In this case, it's a square of a difference because I have a subtraction sign there. Step 4 then says on the variable side of things, this left side here, I need to factor the square of the sum or difference into its factored form. Now again, you can go through and do the entire factoring process if you would like to, or if you've shown these 3 steps of work, the number that we have inside the parentheses right here is going to come down and get written right into that set of parentheses. So this thing is going to automatically factor into t minus 5, all raised to the 2nd power. The opposite side, it's just going to be a number. I think this is going to be 36 with this, if my mental math is correct. And yeah, that looks correct here. So now I have this left side fully factored. It equals a number. And now I can solve this thing using extraction of roots, the 10.1 material. So I'm taking the square root of the left side, square root of the right side. I'm getting t minus 5 is equal to plus or minus 6, because I could have a positive 6, it could have a negative 6 on that right side. I'm going to move us up here, and I'm going to split this into our 2 scenarios. An instance where we have t minus 5 equals a positive 6, and where t minus 5 equals a negative 6. And we're solving each of those individually. So I'm adding to the left side, I'm getting t equals 11. Adding to the left and right side over here, I'm getting t equals, what's that again? Whoops, I should probably write that it's a plus 5. That makes a bit more sense now. Perfect. So now I'm getting t equals 11, I'm getting t equals negative 1. These are going to be our 2 answers that we have showing up here. We'll see this in more examples, but the step right here, this is going to save you a lot of time if you write that out for yourself. This is our shortcut for not having to do the full factoring to get to this step here. Make sure you're doing that and writing that out in all of your problems. Looking at example 2, we're starting with 2m squared plus 16m minus 8, all equaling 0. Following our process like we did with our previous problem, we're going to manipulate this equation so the constant is on one side, variables are on the other side. So I need to get rid of this minus 8 that I have here. And to do that, I'm going to be adding 8 to both sides. Again, my variable terms all on one side, the m squared and the m. And then my constant term on the opposite side. So here we go. Variables here, constant on the other side, good to go there. Our second step says to obtain a coefficient of 1 for x squared, in this case m squared, by dividing all terms by the coefficient of x squared, in this case m squared. My coefficient here is 2. I absolutely need that to be a 1 to go through this process of completing the square, so I need to divide every single term by that 2. We'll see in some later examples this is going to mean that we are going to have some fractions showing up from time to time. That's okay, that's perfectly fine, that happens. It's just part of the process as we're going through and solving this thing. But now I have a coefficient of 1 in front of this m squared term, and I'm good to go there. Our next step, from the variable terms, we take half the b value and we square that, and then we add that to both sides of the equation. So my b value here is this positive 8, and like we did with the previous problem, I would recommend writing out for yourself number and the sign. So I'm taking half of 8, that's going to give me a positive 4, that's going to be squared. 4 squared is 16, and that's what I'm going to be adding to both sides of this equation. So I'm going to end up having m squared plus 8, plus 8m. And again, just to highlight this a bit more, I'm just going to write this in blue. You don't have to do this, but I think it's worth seeing where these are coming from is all. So this 16 we got at the very end, that just gets added on to both sides of this equation. Remember, whatever I do to one side, I have to do to the other side as well. I'm going to move this up just because I'm running out of space here, and I want to try and keep everything together if I possibly can. So once I have a square of a sum, square of a difference on this left side here, that's perfect. We move on to step 4, which says on the variable side, we are going to factor the square of a sum or difference into its factored form. And again, we have this, I'll do it in a different color this time. We have the line right here, we have this 4, that's going to be our shortcut to jump right into the factored form of m plus 4 squared equals, then we have 20 showing up on the opposite side. So once we have this thing factored, now we can solve this remaining equation using the extraction of roots method that we learned from 10.1. So I'm taking the square root of both sides. On the left side, I get m plus 4. On the other side, I get plus minus. And I'm going to rewrite and simplify the square root down. That's going to give me 2 square root of 5. You can learn or use the previous methods that we have for simplifying radicals down as necessary. But we're going to be getting 2 square root 5 showing up there. And now at this point in time, I've got this positive and negative here, so I need to split this up into my 2 scenarios. Where is m plus 4 equal to a positive 2 square root 5? And where is m plus 4 equal to negative 2 square root 5? In both instances, I'm going to be subtracting 4 from both sides of the equations. I'm getting m equals negative 4 plus 2 square root 5. And I'm getting m equals negative 4 minus 2 square root 5. This can also be written as m is equal to negative 4 plus or minus 2 square root 5 as well. It should be noted that while we have these 3 ways of writing out our final answer, make sure that you are doing and following the policy and the form that your particular instructor or program that you are using is looking for. So it's either going to be the instance where we have our 2 answers here or 1 answer with the plus or minus in it. Generally, that's our best routes and options for writing out our final answer here. But otherwise, there's example 2. So here in example 3, we're seeing a not so uncommon situation where we are starting with something that is not in standard form or even close to standard form on one side of this equation. This is, again, not an uncommon occurrence and often means we need to do some setup and prep work before we can start using the process that we have for completing the square that we went through. So to do that, I'm going to multiply and distribute everything through on this left side of the equation. Again, I want to get this thing into standard form because I need that to be able to go through and actually solve this thing. So I should be getting this answer here. We should be getting x squared plus 4x minus 4, combine like terms. And I get 4x plus 3x minus 4 equals negative 25 over 4. So now that I have this left side in standard form, I can now go through and rewrite and solve this thing accordingly with the process that we learned. So to do that, I want to get the constants all on the right side of this equation, or opposite the variable terms on that side. So to do that, I'm adding 4 to both sides. On the left side, I'm getting x squared plus 3x. That equals to, and then negative 25 over 4 plus 4. That's going to give us negative 9 over 4 as a fraction. My recommendation to you is to keep everything as a fraction if possible. Decimals get kind of gross if they go beyond 1 or 2 decimal places, and I would not recommend using them if you have the choice between that or a fraction. Keep everything as a fraction. So once we've done that, we need to make sure that we obtain a coefficient of 1 in front of this x squared term. That's already been taken care of for us. Excellent. So we can move on to step 3. This is where we're taking half of the b value and squaring it. And again, write that out for yourself. So half of 3 squared. Half of 3 is going to be 3 over 2. Squaring that. And then that is going to give me a positive 9 over 4. Again, I have fractions showing up here and here. That's fine. I recommend leaving the problem like that and leaving the numbers that you're working with as fractions. So zoom this out here just, actually move it up. So now, after we've done that, remember we need to add that number that we found, squaring it. We are adding that to both sides of this equation. So that's going to mean I'm going to have plus 9 over 4 on the left side. Let's make that a better 4. There we go. Equals, and I'm having a negative 9 over 4 plus 9 over 4 on the right side. Step 4 says on the variable side, we have the variables over here, I need to factor that thing into the square of a sum, square of a difference, whichever one that would be. And remember, this guy right here, that's our shortcut. It's going to always get us to that factored form without having to go through the full factoring process. So this left side is going to factor into x plus 3 over 2 squared. And on the opposite side, I have this negative 9 over 4 plus 9 over 4. That's just going to become 0. And now I can use extraction of roots. Take the square root of the left side, take the square root of the right side. I'm getting x plus 3 over 2 is equal to, the square root of 0 is just going to be 0. I don't need to include the positive or the negative of that because 0 is neither positive nor negative. So from here, now I'm just subtracting 3 over 2, both sides of this equation, and I'm only going to get to one answer in this instance, and that is x is equal to negative 3 over 2. I do want to note, as a heads up, so where you don't have any false assumptions that are showing up here, the fact that I got one answer has nothing to do with the starting thing written in this form, nor does it have anything to do with this number starting off as a fraction. It's just how the numbers worked out when we went through the problem. So be careful in making an assumption that if something's written in this form, I'm only going to get a certain number of answers. It's not the case at all. It's just a coincidence for this one particular example. And here we are at our fourth and final example. We're starting off with 5y squared plus 3y is equal to 10. So our first step again is to manipulate the equation so the constant term is on one side, variable terms on the other. We have that, so we're good to go there. Our second step is to obtain a coefficient of 1 for x squared, in this case y squared, by dividing all terms by the coefficient of x squared, or in this case y squared. So I do not want this 5 out front here. The only way I can get rid of it is if I divide that by 5, this term by 5, and the next term by 5. Remember that whenever you have to do this, every single thing, regardless of whether it has a nice number in front of it or not, and I say nice like this, where we're going to get a nice 2, or we get a fraction here, doesn't matter. Everything needs to be divided by that coefficient. There's no exception to it. A lot of people forget that. They only do this term and this term, and then this one gets left out and we get wrong answers showing up. So everything divides by 5. Excuse me there. All right, so now that we have a coefficient of 1 in front of here, that was our second step. Third step is to take half of this b value and square it. So again, we have fractions showing up here. That's fine. We have calculators we can use to go through and get to our answer, or at least assist us to get to that answer if necessary. So half of 3 over 5, I'm multiplying those fractions together. I'm getting 3 over 10 squared. And then when I square that, I'm going to be getting 9 over 100. And that is what's going to be added to both sides of this equation. So on the left side, I'm getting y squared plus 3 over 5y. And then I'm adding 9 over 100 to this left side. On the opposite side, I have 2 plus 9 over 100. Again, whatever I do to add to one side, I have to add that exact same thing to the other side as well. So moving us up here, just keep everything together. On the right side of that equation, I'm going to rewrite that into being one single fraction, because I don't want to have that split up as two things adding together. And on the left side, I'm going to factor that. So the left side factors into y plus 3 over 10 squared is equal to, and then the right side is going to be 209 over 100. And yes, we have fractions showing up over here and a little bit over here. That's fine. We can deal with that. We will deal with that accordingly. Once I have it written in this form, now I can solve this using extraction of roots. So I'm going to take the square root of the left side, square root of the right side. Left side, I end up getting y plus 3 over 10 is equal to plus or minus the square root of 209 over 100. Now it turns out that I actually cannot take the square root of 209 and get a very nice answer, but I can take the square root of 100, the denominator on the right side, and the square root of 100 is going to just give me 10. So I'm going to leave the numerator as the square root of 209, and I'm going to have the denominator become 10. It's a slight rewrite, but I think it's very, very useful, and it's something that we have to do because we cannot have radicals, I should say, containing fractions in them. We need to rationalize the denominator, and that's what we just did there. So because this whole thing is going to stay particularly gross, and I can't really do a whole lot to combine anything together or rewrite it down, I'm going to leave it in this form, and then just move this plus 3 over 10 to the opposite side. So I'm going to subtract 3 over 10 from the left side. I'm subtracting 3 over 10 from the right side. And I'm getting y equals negative 3 over 10 plus or minus the square root of 209 over 10 as well. Now, depending on the instructor, the online program, whatever you are using, you can leave your answer in this form, or you can do a slight rewrite and write everything as one single fraction. Because the denominators are the same, I can put the numerators together. What that's going to look like is negative 3 plus or minus the square root of 209, all divided by 10. So again, double check with your instructor, double check with the answer key of the book you're using or the online program if they prefer you to write your answer in one of these two forms. But either of these should work for our final answer here. So as a quick recap of everything that we covered with the 10.2 material, remember that our goal is to go through and rewrite our quadratic equation into a perfect square trinomial. We then factor it, and then find our answer using extraction of roots, the 10.1 material in there. We are going to need to remember and use the square of a sum and square of a difference on a regular basis with the completing the square process, so reference back to 7.4 if necessary. We had our very quick preliminary how to make a a perfect square trinomial example we had here. Again, this is unique to just this example. There are a lot of other processes and other ways that we go through and use this, but this is just to show how we're using half our b value and squaring it. We then have our overall process that we're using. I don't know why I'm getting a little mark up there. There we go. We then have our overall process to go through and solve these things using the completing the square method. If you are going to use this method, again, highlight, put stars around, whatever you need to do for step 2. We are going to be using that on a regular basis, and a lot of people miss that as they are going through these problems, and that costs them a lot of points. But I'd recommend writing this down for yourself and pausing the video here if necessary to do so, to make sure you have all of this and you can follow these steps as you go through and solve these examples. We then had 4 examples that we went through, the different ways that we can be given something at the very beginning of these problems. And then we have some practice problems if you'd like to go through and give those a try. I'd recommend pausing the video here if you'd like to give these a shot. We're going to scroll down here shortly to the answers for each one of these problems. And here we have our answers showing up. It should be noted, as we see with all of these, we can and will still have problems with radicals showing up in here, as we see with several of these examples. Make sure you're double checking with your instructor if they want something written in this radical notation, or if your instructor or online program is okay with you using decimals as your final answer. Just make sure you're clarifying that before you write out and circle your final answer for each problem. But other than that, that is everything for our 10.2 material and one of the processes that we have for completing the square.